Alright, so we'll start with the ARM stuff. And the first thing you have to do is get this ARM emulator going. So it's starting at samsclass.info. You go to the ARM assembly page, which is exploit development. And then here in ED41, there is a machine to download. The VMware one works fine, and the VirtualBox one works if you have a relatively recent version of VirtualBox anyway. So you download this file, unzip it, and run it. And you will have, I think I've got it here, yeah. It will launch this virtual machine, which is an Ubuntu 20 headless server. And as commonly happens with Linux, it boots up and asks you to log in, and it is still putting out system messages after the login prompt, so it looks kind of funny. But you'll log in with student and the password that you see on the instructions there, student and capital P at SSW0RD. That gets you in. Now here, we're in the console of this headless server, and the console is not a very good place to work because you can't copy and paste into it, and the screen doesn't scroll in a good way, so you can't use tools like Nano and such. So the only thing I do in the console is get the IP address with IPA, and then I connect with SSH. Now this machine has a lot of network adapters, but the first one, ENS33, after the loopback, is the one that we can use to SSH in. These others are used by the QEMU emulated virtual machines that are inside this virtual machine. So we're going to have two layers of virtualization. Technically, one layer of virtualization to get from my Mac operating system to this Ubuntu Linux, and inside there, emulation. We're going to emulate ARM processors. And the point of all this is, even if you have Intel hardware, which I do, and most people do, we can emulate ARM hardware and play with the ARM commands. So I'm going to connect to that address, 172.16.123.130. Let me clean this up. I've got some old stuff here. Sudo power off, perhaps? All right, there we go. All right, let me move this one aside. And I'll exit this one. All right, and clear. All right, so once you've found that IP address, which is up there, 172.16.123.130, then you can SSH to that. The username is student. Here, username is student, and the password is that, capital P at SSW0RD. So that's what you do. You SSH in as student here and give it that password. And now you've got a terminal you can use that you can copy and paste into, and that will scroll properly and such, which is better than the console. And we're going to need like up to 3 of those sessions as we go through things here. Because the only confusing part about this is you're controlling a lot of different machines. So that is the Ubuntu host. And the Ubuntu host, if you do uname -a, the Ubuntu host is running on Intel hardware, x86 64-bit hardware. So this is not really very interesting. It's only there as the host to run the ARM VMs. So here is the command that launches the ARM32 QEMU emulator. Or rather, it shows you the emulators, and here it is. This is a Raspberry Pi, and right now it's shut off. So we're going to emulate a Raspberry Pi 32-bit ARM, and you launch it this way. It's the QEMU command that turns on the QEMU emulator, and so there it goes, running a bit slow, but this is the Raspberry Pi boot up. See, welcome to Raspbian, which is very much like Ubuntu and runs on 32-bit ARM. that's happening, maybe I can fix the traditional defect in my OBS presentation. Every time I restart the webcam, alright, does weird things. Alright.
Go ahead, I'll show you. I got training going on, so forgive me when I see my got loud. Fine, yeah, I forgot you guys were coming today. I got you. I saw some of the doors like, who is this? Well, I'm just going to mess with the thermostat. He's already started outside.
All right. Let's see, it started. Now it started the Raspberry Pi. And so you log in as Pi and Raspberry. And it is a bit slow, of course, with 2 layers of virtualization. But it's good enough. All right, so if you do uname -A, you'll see I am in fact running on ARM v6L, which is 32-bit ARM. All right, so we're going to use this later. Now we just want to get it going. You can turn it off from inside the Raspberry Pi with sudo power off. You can also turn it off from the Ubuntu host by unplugging the, turning off the virtual machine from the other end too, with more vir sh commands. All right, so that's the 32-bit ARM emulator. And I'll just let this finish going down. There we are. Now I'm back to the Ubuntu host. And now to start the ARM64 VM, I just go to the home directory, where I am anyway, and I run a script, start ARM64. It's in that directory. And what I did was I loaded a version of Alpine Linux that's 64-bit on ARM. Alpine Linux is just a very small Linux, sort of like Raspbian. I came across it from a Capture the Flag forum contest a while ago. You can make very small, very fast Linuxes. I think like 30 megabytes is enough for a Linux distribution. So it's very nice for simple little projects like this. And it had an ARM version, so it was like Raspbian. It was a nice simple thing to install that was so small and lightweight that it runs okay even under these conditions where the performance is pretty bad with 2 layers of virtualization here. And so here it is starting AArch64, which is 64-bit ARM. And like I said, it takes some patience. You want something that really takes patience, try running Windows in a virtual machine through Rosetta on the Mac M1. That is essentially unusable. It's like a machine without enough RAM. You have to click and wait 10 seconds and type and wait 10 seconds. It's horrible. This is okay once it gets going. It's slow to boot up, but once it's going, it responds well enough to command line commands. There we go. Eventually we're going to get to an Alpine login down here. There we go. Keeps on complaining about clock skew, and I don't really know what that means, but it doesn't seem to be too much of a problem. So, all right. So now I can log in with student and the same password, capital P at SSW0RD. And now that I'm in, one problem with it is for some reason it sets the wrong default gateway, so you can't network by default. You have to fix that. You can see the problem here. If I ping google.com, let me shrink this down. All right. And I can copy and paste into this window, which is nice. I can't ping Google. I get no replies. And you can see the problem. I say, there we are, with IP route. The default route is ETH1, which is a post-only adapter that doesn't get to the internet. So you have to delete that with sudo route del default. And for some reason I was unable to make this automatically happen at boot up. Then give it a password. And now IP route shows a different default going out ETH0, and now you can ping Google. So you have to do that each time you boot it up. And by the way, you cannot suspend this Ubuntu host and unsuspend it and carry on. You have to go through a clean startup each time you start it if you want these emulated virtual machines to work. All right. And so now you're in, and now again you can just do uname -a to see what you've got. And you have AArch64, which is 64-bit ARM. And again, you can shut it down from inside with sudo power off. So that's all there is to this project, getting your 32-bit and 64-bit ARM machine running. And so in the next one, I'll start talking about how we make buffer overflow exploits in both of those. So I'll stop this recording.